One possibility that keeps surfacing is called early dark energy, a hypothetical burst of extra expansion that occurred in the first few 100,000 years after the Big Bang, then vanished. If something like that happened, it would change the conditions in the early universe just enough to shift the Planck prediction upward, closer to 73, without breaking the other things the Standard Model gets right. Mark Kamionkowski, a cosmologist at Johns Hopkins who has helped develop this idea, has compared it to the universe receiving an unexpected kick right after it was born. A nudge that would have rippled forward through 14 billion years of expansion, slightly altering the rate we measure today. Nobody knows if early dark energy is real. No one has detected it, but it's one of the few ideas that could solve the Hubble tension without demolishing everything else that works. The tension would be enough on its own, but Webb delivered a second blow. Almost as soon as the telescope started observing, it found galaxies in the early universe that had no business being there. Not small, dim, infant galaxies, which is what the Standard Model predicted at those distances. Massive ones. Galaxies seen as they existed just 500 to 700 million years after the Big Bang, some of them rivaling the Milky Way in mass. A galaxy that took our own neighborhood 13 billion years to build had apparently assembled itself in under a billion. Mike Boylan-Kolchin, an astronomer at the University of Texas at Austin, ran the numbers. In a study published in Nature Astronomy, he showed that 6 of the earliest and most massive galaxy candidates observed by Webb pushed right up against the absolute limit of what the Standard Model allows. To form galaxies that heavy, that fast, nearly every available atom in their surrounding dark matter halos would have had to convert into stars. In a normal universe, that conversion rate sits around 10%. 90% of the gas just never gets around to forming anything. It's too hot, or it gets blown out by radiation, or it simply drifts. These galaxies seem to be running at 100% efficiency, like a factory that somehow turns every scrap of raw material into finished product with zero waste. Physics doesn't work that way, not in any model anyone had built. The initial reaction was, frankly, alarm. If galaxies this massive really formed this quickly, then either our models of galaxy formation are deeply incomplete, or the Standard Model of cosmology itself needs revision. Some physicists proposed that new particles or forces might have existed in the early universe, accelerating star formation beyond anything current models predict. Then came a correction. Katherine Chworowski, a graduate student also at the University of Texas, led a study published in mid-2024 that re-examined the data. She found that many of the apparently overmassive galaxies were being fooled by their own black holes. These galaxies, nicknamed little red dots because of their color and compact size, hosted black holes that were rapidly devouring gas. The friction from all that infalling material heated it to extreme temperatures, and that heat radiated outward as light, lots of it, blending with the starlight of the galaxy itself.